The number of tangents that can be drawn to two circles depends on the relative positions of two circles. So we shall describe the various possibilities of the relative positions of two circles. We will be discussing the various terms like common tangents, internal center of similitude, external center of similitude, direct common tangents, transverse common tangents, etc. So first of all, what are called touching circles? Two circles, the circles S is equals to 0, comma S dash is equals to 0 are said to touch each other if they have a unique point in common. A unique point in common. That unique point is called, the common point is called the point of contact. So, for example, let there be two circles like this. Let there be two circles, this as well as this. They both are touching at one common point. This common point is called the point of contact. What is this point called? Point of contact. And these circles are called touching circles. So, not only this, if we take the another situation, for example, this circle and this circle. So for both of them, so they have one point in common where these two circles touch each other. So this point is called the point of contact, and these circles are called touching circles. So just now we have seen what is common tangents, what are common tangents all about. So these common tangents, again we can classify it into two categories. One is direct common tangents and second one is transverse common tangents. So let us see what is direct common tangents. A common tangent L is equals to 0 of the circles S is equals to 0, S dash equals to 0 is said to be a direct common tangent of the circles S is equals to 0, S is equals to 0, comma S dash equals to 0 if the two circles lie on the same side of L equals to 0. That means, let us take two circles. This is one circle and this is another circle. So, this line is a tangent as we have discussed before. So, this line touches, see this, if these two circles lie on the same side of L equals to 0, this line is common to both the tangents. This line at a time is touching both the circles. Therefore, it is said to be a common tangent. And these two circles S is equals to 0, S dash equals to 0 are lying on the same side of the line L equals to 0. What I am talking about? Because see this, for this line, one circle and this circle, these two circles are lying on the downside. Otherwise, if I take this also, for the time being, for this, these two circles lie on the same side of the line. Same side of the line, I am mentioning about for this line, one circle lies on one side. For this line, for example, one circle lies on one side, another circle lies like this. So these two circles lie on the opposite side of the line. Okay, but here it is not like this on opposite side or either side. Both are lying on the same side. These two circles are lying on the same side of L equals to 0. Then these tangents are called common tangents. Now let us see what is transverse common tangents. Transverse common tangents. So a common tangent L is equals to 0 of the circles S is equals to 0 and S dash equals to 0 is said to be a transverse common tangent. Is said to be a transverse common tangent of the circles S is equals to 0 and S dash equals to 0 if the two circles S is equals to 0 and S dash is equals to 0 lie on the same side, means direct common tangent. But here on the either side, either or opposite side of L equals to 0. What I am trying to tell you is, let us take two circles. Let us take two circles like this. So this is S is equals to 0 and S dash is equals to 0. And this is a common tangent. This is a common tangent. This is a common tangent. And this tangent is, for example, L equals to 0. Okay. So the two circles lie on the either side or opposite side. Earlier it is for the line, the two circles like this and they are lying on the same side, or two circles are like this, they are lying on the same side. But here these two circles lie on the either side of L equals to 0. So such tangents are said to be transverse common tangents. Not only this, if I take another situation, this like this, so this is also a transverse common tangent. And the next one is internal center of similitude. Internal center of similitude. Just now we have seen the transverse common tangents, right? What are the transverse common tangents? Again I am telling you, if I am taking S is equals to 0 one circle, another circle S dash is equals to 0. So this line is common to both of them. This line is common to both of them. Okay. So what is this? This is a line L equals to 0 which touches both the circles. Therefore it is a common tangent. The two circles are lying on the either side or opposite sides of this L is equals to 0. Therefore, this line is said to be, this common tangent is said to be a transverse common tangent. Like that, actually we can have another line like this. So this line is also a transverse common tangent. Why? Because this is another line L dash equals to 0. For this L dash equals to 0, the two circles. So the situation is something like this now. So So like this. Okay. This line I'm talking about, L dash equals to 0. This is S is equals to 0. This is S dash equals to 0. So this line is a common tangent first of all. Why? Because this line touches both the circles simultaneously. Okay. But these two circles, if I see, so these two circles are lying on the either side of the these two circles are lying either side of the line L dash equals to 0. Therefore, what are these common tangents called? Transverse common tangent. And this transverse common tangent's point of intersection. So, the point of intersection of the pair of transverse common tangents, pair of transverse common tangents is called internal center of similitude. Internal center of similitude. So this is C1 and this is C2. What is C1, C2? C1 and C2 are the centers of the two circles. So what is this? This is the internal center of similitude. The point of intersection of two transverse common tangents is called internal center of similitude. Now the next topic is external center of similitude. So let us take two circles. This is S is equals to 0 and this is S dash is equals to 0. So if I am taking one line like this, okay, if I am taking one line like this, what is this line called? For example, L equals to 0. So the two circles S is equals to 0 and S dash equals to 0 are lying on the same side. It is not that one circle lies on one side, another circle is on the opposite side of L equals to 0. It's not like that. So two circles are lying on the same side of L equals to 0. And if I take another line, okay, so let us take the earlier one is L equals to 0 and this one is L dash equals to 0. So both these lines are what is this line? It is a direct common tangent and this is also another direct common tangent. So these direct common tangents are meeting at one point, which is, so for example, this is C1 and this is C2. So this is C1 C2 line join. Okay, if I extend this point, for example, let us take Q. The point Q is lying on the external point of the line joining of the two centers. That is why it is said to be external center of similitude. External center of similitude. So how do we define now? External center of similitude, the point of intersection of two transverse direct common tangents. Two direct common tangents is called external center of similitude. Why the name came like that? Because this point of intersection is lying on the exterior of the line joining of the two centers. And earlier, for example, this is the one transverse common tangent, and this is another transverse common tangent. Let this transverse common tangent touch here, and for this it touches here, for example. So this is one transverse common tangent, this is another transverse common tangent, and the point of intersection of this transverse common tangent is, for example, this P. So this P is called internal center of similitude. Can you guess how that name comes? Because this point of intersection of two transverse common tangents is lying on the interior of the line joining of the two centers. That is why internal center of similitude name came. So I am just concluding, the point of intersection of two direct common tangents is the external center of similitude, and the point of intersection of the two transverse common tangents is the internal center of similitude. Also, two intersecting common tangents and the line joining the centers of the two circles are concurrent. What is said to be concurrent? Three or more lines are said to be concurrent. All these lines are said to be concurrent if they have one point in common. So that is why here two intersecting common tangents. For example, two circles are like this. Let us take this as one direct common tangent, and this is another common tangent, right? So these are the two common tangents, two intersecting common tangents. So these two common tangents are intersecting at this point. Okay, so that means, for example, if you take like this, so these two lines are intersecting, and the line joining of the centers of two circles. So the line joining of the centers, that means this. So the line joining of the two intersecting common tangents and the line joining of the centers are concurrent, because all are passing from this point, and this the point of intersection. The point of intersection of the common tangents so you may even this is the direct common tangents. The direct common tangents example I have taken and explained this. Otherwise, you may even take the transverse common tangent as well, because this is the transverse common tangent and this is the transverse common tangent. Okay. So the point of intersection of the transverse common tangent and the line joining of the center all are passing from this point. So therefore, the two intersecting common tangents, transverse common tangent and the line joining of the centers are also concurrent lines. Similarly, the point of intersection of the common tangents and the line joining of the centers of are collinear. What is collinear? So all are lying on the same line. So for example, let us take this and this. The point of intersection of the common tangents. That means, for example, this is one common tangent. To be more specific, direct common tangent, and this is another common tangent. So the point of intersection of the to the point of intersection of the common tangents. That means I am talking about this. And the line joining of the centers. That means C1, C2. This is the line joining of the centers. If I extend, see this C1, C2 and the point of intersection of the direct common tangents. Let us suppose this to be P. So C1, C2, P are all lying on the same line. That is why it is said to be, they are said to be collinear points. Not only that, if I am taking a transverse common tangent, for example, and one transverse common tangent like this. Okay. So, and let us take the point of intersection of the transverse common tangent to be Q. What is Q? Q is the internal center of similitude. P is the external center of similitude. P is the external center of similitude, which is the result of two direct common tangents. Q is the internal center of similitude, which is the result of two transverse common tangents. And now C1, C2 are the centers of the two circles. The line joining of the centers of these two circles, C1, C2, Q, P are all lying on the same line. Therefore, line joining of the center C1, C2, internal center of similitude, external center of similitude are all lying on the same line. So, C1, C2, P, Q are said to be collinear points. So, now we shall describe the various possibilities of the relative positions of two circles. See here, if C1, C2 is greater than R1 plus R2, then the two circles do not touch. The two circles neither touches nor intersects, and one circle lies completely outside the circle. So, total number of common tangents is equals to 4. Number of direct common tangents. Number of direct common tangents is equals to 2, while the number of transverse common tangents is equals to 2. So, here two circles, this is C1 and this is C2. What are C1, C2? C1, C2 are the centers of the two circles. And see here, this is one direct common tangent. And this is another direct common tangent. This is another direct common tangent. And this is one transverse common tangent. And this is another transverse common tangent. So, and if you extend these two, see. So this is one direct common tangent and this is another direct common tangent. This is one transverse common tangent. This is another transverse common tangent. Why direct common tangent here? Because these two common tangents touch these two circles, and the point of intersection lies on the line joining of two centers. This point of intersection lies outside the line joining of the centers of the two circles. That is C1, C2 is this. So this point of intersection lies on the line joining this point of intersection of the common tangents lies completely outside the line joining of C1, C2. So this is what external center of similitude. And what are these two? These two are transverse common tangents because these two circles lie on the either sides of this common tangent. Therefore, this is transverse common tangent and this is another transverse common tangent. So, with respect to this line, the two circles lies on the opposite or either sides of the two circles, and this is what internal center of similitude. Therefore, two direct common tangents and two transverse common tangents are possible. The next case is if C1, C2 is equals to R1 plus R2, then the two circles touch each other externally. So here total number of common tangents is equals to 3. So number of common tangents is equals to 2, while the number of direct common tangents. So direct common tangents is equals to 2. Number of transverse common tangents is equals to 1. How? Let us see this. So these are the two circles having centers C1 and C2. Okay, so this is one line which is common to both the circles. This is one direct common tangent, and this is another direct common tangent. Okay, so this is another direct common tangent. Let us see. So let them meet at one point. This is called external center of similitude. External center of similitude is the point of intersection of two direct common tangents. Can you guess why these two lines are direct common tangents? Because with respect to this line, these two circles lie on the same side, and with respect to this line, these two circles lie on the same side. Okay, and what is this? This line is these are direct common tangents, and this is transverse common tangent, because with respect to this line, the circles S is equals to 0 and S dash equals to 0 lie on the opposite side or either sides of the circles. Therefore, when C1, C2 is equals to R1 plus R2, the two circles touch each other externally. One circle lies completely outside the circle. So here one direct common tangent, and what is this point of contact? This is the internal center of similitude, and this is external center of similitude. So the next relative position is if C1, C2 is lying in between R1 plus R2 and R1 minus R2 modulus. R1 minus R2. So under modulus less than. That is C1, C2 is lying in between the difference of radii and the summation of radii. So why R1 minus R2? It could be R2 minus R1 as well. So if the condition is this, then the two circles, then the two circles cut or intersect each other. So the number of common tangents is equals to 2. So number of direct common tangents is equals to 2. So number of transverse common tangents is equals to 0. How? We'll see now. So these are the two circles, they are intersecting each other. Okay, and so this is one line common to both the circles. So these are the points of contacts. Therefore, this is called the common tangent, which is a direct common tangent, because these two circles with respect to this line lies on the same side, down side of the line. And here this is also another common tangent. So this is a direct common tangent. Both are direct common tangents, and this point is the external center of similitude, and this is the common chord, because this is the chord common to both of them. What is this? This is the common chord. So therefore there is no transverse common tangent possible here. If C1, C2 is equals to modulus of R1 minus R2. So I have told you before, C1, C2 is equals to modulus of R1 minus R2 means difference of the radii. It could be R2 minus R1 or R1 minus R2. If C1, C2 is equals to R1 minus R2, then the two circles touch each other internally. Therefore, the number of common tangents is equals to 1. So, this is that direct common tangent. This is that direct common tangent which we are mentioning here. So this is C1 and this is C2. Okay. So can you guess what is this called? Is this a direct common tangent or a transverse common tangent? Because for this line, these two circles lie on the same side of the common tangent. Therefore, this common tangent is called the what? So here C1 C2 line joining. This point is called the external center of similitude. Whenever external center of similitude came, there is a possibility of a direct common tangent there. Therefore, direct common tangents, number of direct common tangents is equals to 1. So, number of transverse common tangents, number of transverse common tangents is equals to 0. Because, so what is the direct common tangent? So, with respect to a line, if the circles S is equals to 0 and S dash is equals to 0 lies on the same side of the line, the circles S is equals to 0 and S dash equals to 0 lies on the same side of a line, then that line is called the direct common tangent. So if you are struggling with this, no problem. So C1, C2, this is the line joining of the two centers. So, and if this point of contact is the outside of the line joining of the center C1 and C2, therefore it is an external center of similitude. Whenever external center of similitude exists, there is a possibility of a direct common tangent. Therefore, the number of direct common tangents is 1 and there is no transverse common tangents. If C1, C2 is less than R1 minus R2 under modulus, then one circle lies completely inside the circle. In this case, there are no common tangents possible. So this is C1 and this is C2. So you can see there is no common tangent possible in this case. And the last condition is if C1, C2 is equals to 0. That means for both the circles, the center is same. That means the concentric circles. So the center is unique. So center is only 1. So the distance between C1 and C2 is equals to 0. So then the circles are concentric. In this case also, there are no common tangents. So these are the full possibilities of the relative positions of two circles. Now, the theorem is let S is equals to 0 and S dash is equals to 0 be two circles with centers C1, C2 are the centers of them, and R1, R2 are the radii of their circles. If P, Q respectively the internal center and external center of similitude. So this is the direct common tangent. This is the direct common tangents, and the point of intersection of the direct common tangent is this Q is called, what is this Q? Q is the external center of similitude. And what is P? P is called the internal center of similitude, because this is one transverse common tangent and this is one transverse common tangent, and P is the point of intersection of the transverse common tangent. So what is P? P is the internal center of similitude of the circles. Then this P divides C1, C2 in the ratio R1 is to R2 internally. So C1, C2 is this. C1, C2, C1, C2. This P is the P divides C1, C2 in the ratio internally. So for example, if we know this is X1, Y1 and this is X2, Y2, then P divides C1, C2 in the ratio, for example, R1 is to R2. Then first year we have learnt the point P. P divides AB in the ratio L is to M, then Lx2 plus Mx2 by L plus M, Ly2 plus My1 by L plus M. So this P is equals to how much? R1x2 plus R2x1 by R1 plus R2, comma, R1y2 plus R2y1 by R1 plus R2. Similarly, this Q divides C1, C2 externally. So Q lies on the line joining C1, C2 externally. Q is equals to R1x2 minus R2x1 by R1 minus R2, R1y2 minus R2y1 by R1 minus R2. So this we will be using while solving the problems, simply because see this. So this is the common tangent and this is the radius. So these two are perpendicular to each other. So if I see here, if I take this for both of the circles C1AQ, see this C1AQ and C2BQ. So these are the similar triangles because the angle and 90 degrees. So angle property C1A by C1A by C2B is equals to, that is opposite to these angles and opposite to this 90 degrees. So what is C2Q? Then what is C1A? R1. What is C2B? R2. So this C1Q by C2Q is equals to C1Q by C2Q is equals to how much? R1 by R2. So similarly, actually transverse common tangents also we can discuss, which is not important. So these are the two results that we have to bear in your mind while solving our problems.